One more time. Ah, helps if I pull the slide.
Very good. Hey,
Okay.
good to see you.
Good to see you, sir.
All right, can you share out your screen and do you want to do your AV checks and stuff?
You have to enable sharing for me.
Is that not spotlight for everyone? Allow to record multi-pin. Why the heck can I not give you that? That's odd.
Just hopping on over. How's everyone doing over here?
Hey, doing all right. I'm looking into trying to give Dave the ability to present and share, but he says he cannot, and I can't seem to find that option either. So I don't know if I have that option too.
I believe if your name has speaker on it, you should be as a panelist. Let me just check. Dave, do you see this message here?
Yes, I do.
Okay, so you should have full ability. Do you see the share screen button on the bottom of the bar?
Yes, I do. But when I hit it, it comes up host disabled participant screen sharing. Ooh, that's hard to say early in the morning.
Oh, that's really weird.
So I see an advanced sharing options, only host or all panelists. I'm changing that over to all panelists. I don't know why that was set to all hosts. So
that should do it.
There we go.
Woo! So sorry, but it's so funny. This happened the last GroupBy as well, and I'm like, I don't even know why they put this setting in. Like, what's the point of a panelist if only one person can screen share? But glad to see it's working. Thanks for the tech support. I'm just going to be lurking in the shadows if you need anything at all. But you're going to do awesome, and thanks for speaking.
Okay. And I have roughly 75 minutes.
Yes, you have 75 minutes. There is a 15-minute buffer between sessions. So if you happen to go a few minutes over, that's not the end of the world. No big deal. I will probably now. Actually, one of my questions as moderator is that do you want me to give you time checks? Say, hey, you're at 60 minutes or anything like that, or do you have a clock handy and you'll track your own time? Well, what's your preference?
I'll just start a stopwatch. So
okay, very good. While I'm here, a couple of other bookkeeping questions. How do you prefer to handle Q&A as they come in? Are you going to monitor the chat yourself, or would you prefer that I monitor the chat for you, which I'm happy to do? And then the second half to that is, do you want me to interrupt you with questions immediately, or do you have specific breakpoints in your session for Q&A?
I'd rather answer questions as they pop up. Otherwise, they tend to get lost in the shuffle.
Okay.
I'll try to monitor the Q&A. Unfortunately, I don't think I can split everything, so I'll stop every so often and go check. But if something pops up, just let me know that you spot.
Okay. All right. I will do that and try and find the right times to kind of cut on in. Last bit of bookkeeping is the intro slides for just the sponsor slide and the code of conduct. Are you going to be handling that, or would you like me to handle that and to kind of kick everything off?
I think I have all three of them there. Yeah, I do.
Okay.
To start. Yeah. Okay. We should be good to go.
All right. Yeah. So if you just happen to have like the GroupBy slide up first, if you want to actually share that out now, then I'll just kind of kick things off at the top of the half hour, and then let you kind of take it away from there. Sound good?
Okay.
All right. Awesome.
So 7 minutes to go. There we go.
Yep. You got plenty of time. Plenty of time to run away and take that one final bio break if you want to, or if you need to as well.
Should be good.
All right, outstanding. Do you happen to have anything else you want to test, like Management Studio or anything else like that?
No, I'm good.
All right, awesome. Well then, all that nonsense aside, how you doing, man?
Doing good. How are you doing?
Doing good, all in all. Although I'm a little concerned, we apparently have our first nor'easter of the season coming up tonight into the New England area. So, we've had tons of rain over the last, 12 hours or so. But I'm reading this morning that, if you thought, last night's storms were pretty heavy, just wait till tonight. I'm like, oh, goody, 15-mile-an-hour winds and even more torrential downpours. So, got that to look forward to tonight.
That's a reason. There's a reason my parents moved away from Boston.
Yeah,
that's one of them.
I hear you there. I mean, I'll be honest. I've been enjoying my time here thus far. In some regards, it's not that much different from Chicago weather-wise and whatnot. So, but the things you do for those you love, right?
Yeah. So where are you at?
So I'm just outside of Boston in Arlington.
Oh yeah.
Yep.
My parents grew up in Charleston and
okay.
Went to high school at Charleston High. My sister graduated from Somerville High.
Oh, very good. Okay.
And I used to go back to visit relatives. Unfortunately, they're all gone now, but
Mhm.
I love Boston. A couple of years ago, I took my wife back there, first time her visit, and she's looking at the Freedom Trail on the map going, I can't walk this. Oh, yes, you can.
That's awesome. Yeah, no, I mean, I don't, I've technically only been a resident of Boston since the beginning of the year, give or take. But you know, I've been doing the long distance thing with Deborah for a while, so I've been coming into Boston quite a bit in the last couple of years prior. But no, you know, it's nice to have settled in. You know, enjoyed a good amount of the summer, all 2.5 weeks of it. You know,
And winter only outlasts 5 months. I mean, what are you worried about?
yeah, exactly. No, I will say though that this year, I mean, it really took a long time before autumn weather really hit. I mean, frankly, we haven't had seasonable autumn temperatures up until a few days ago. But prior to that, it's actually been reasonably warm, which has been really, really nice. So definitely have been enjoying that and the kind of extended, not quite summer that we've had here.
Uh, well, hopefully, sometime later this year, early next year, I'll get to travel again. And I love going to Boston.
Excellent. Well, let me know if you're ever in town. I would love
Okay.
to meet up for a drink or a bite.
Okay.
Yeah. Where are you these days anyway?
I'm in a small town north of Fort Worth and west of Dallas called Justin.
Okay.
We're so small, we just got our third set of traffic lights.
Oh, wow. All right.
And it's one of those things where there's so many Californians and Bostonians, New Yorkers moving to Texas that they're building communities all around me. So my little town that was out in the middle of nowhere is slowly being encroached upon by civilization.
Wow. Is this a situation where you should buy some extra land to hopefully make some retirement money in 10 years after your area explodes and real estate prices skyrocket?
I wish, but it's kind of like Back Bay real estate. If you could afford it, you couldn't buy it anyway.
Right, right. You didn't get in on the market like Somerville, for example, you know,
Yeah.
20 years ago was a heck of a lot cheaper and stuff, you know.
Yeah. Well, I grew up in Southern California, so I was used to watching the real estate market just go crazy,
Mhm.
all the time. So uh, it's a fairly quiet pace of life, and I'm close enough to DFW Airport that when I have to fly out, it's not too onerous of a chore. But
Nice, nice. Yeah, I was actually in Dallas just over a month ago now for a quick overnight hit and run, and it was nice to get some Texas barbecue once again. I did I managed to hit Hard 8 not once but twice.
ooh, very
Um,
good.
you know, I had to go with what was convenient. I would rather get out to Pecan Lodge, but I had to stick near the airport, so Hard 8 it was, which is still a bazillion times better than anything else I can get around here. I mean, thankfully here in Boston, there's some good barbecue places that I've found that are good for the north, if
Yeah.
you will. Because I've had some other really lousy barbecue also. So I'm happy with what I got here, but I was also happy to get some Texas barbecue as well.
Yeah. Well, I will admit when I'm there, I hit the barking crab at least twice to make sure I
Nice.
get my fill of lobster roll. And I used to love going to the legal seafood test kitchen.
Oh
But
yeah, I've read about that. And it's one of those places I definitely want to check out. Haven't gotten around to it yet.
yeah.
All right, awesome. So you got about another 2 minutes before we kick on off. Welcome to everyone who's rolling on in. Feel free to chat us up in the chat or the Q&A panel. I can't remember if you guys actually have access to the chat panel or not, but if nothing else, you definitely got access to the Q&A, and just use that. Just even say comments and say hello or whatever. Be a little peanut gallery if you guys want to. But we'll be underway in another minute or two.
Sounds good.
Any last second things that you need, Dave, from a logistics standpoint?
No, I think I'm good.
All right. All right.
Oops. There we go. So while we're waiting for the clock to hit the bottom of the hour, if you do have questions, please put them up in the chat or Q&A. I'll try to monitor that as I go. I will be speaking up MySQL. So if you have any SQL Server questions left over from the last session, I may not be able to give you even a good answer, let alone an excellent answer. And that dropped 2 participants off. Sorry about that. Well, that happens.
Hey, you want the people who want to be here, right?
Yes, sir.
All right. Well, with that, my clock says it's time, so let's get started. Welcome, everyone, to GroupBy 2021. This is the second session of GroupBy Americas. My name is Andy Yoon, and I'll be the moderator for this particular presentation. Dave, next slide, please.
Okay. There we go.
So a quick bit of bookkeeping. GroupBy does have a code of conduct policy. In a nutshell, just be kind and friendly to each other, right? And if there's anything questionable, just keep it to yourself. You know, that's all we ask. It's pretty simple and straightforward. Just be cool to one another, all right? Next slide, please, Dave.
Okay.
The other thing that we want to say is a quick shout out and thank you to all of our sponsors that have helped to make this GroupBy conference still be a free conference. So thank you to our sponsors. The session immediately following this one will be the sponsor session. So, you know, the sponsors would appreciate some time if you go and hang out with them. So with that, what is it? I'll again be the moderator. Both Dave and I will be monitoring the Q&A and chat panel to see if there are questions that come on in. But otherwise, Dave, the floor is now yours. Please take it away.
Thank you. I've never had a virtual floor like this before. Okay. As Andy mentioned, my name is Dave Stokes. I am a community manager for MySQL products. I've been doing this job for almost 11 years. Long before that, I started with MySQL AB when it was a small Scandinavian startup. I was a PHP programmer in the certification division, and I've been using MySQL since it came out. And today I'm talking about things to speed up your MySQL queries. And this talk, I want you to know the slides are available. I'll point the link out for that. I gave this as a 2-hour talk on Monday. I gave it as a 45-minute talk on Tuesday. So I'm trying to not rush through this. So as you have questions, please bring them up and put them out there. If you need to get a hold of me, I'm at Stoker on Twitter and my email is there. Since I do work for Oracle, I have to put this slide in the presentation. If I get off on a tangent on products that haven't been released yet during Q&A, or I just go off on a tangent, take what I say about future products with a grain of salt. I don't have perfect knowledge of that. So if I say blue and you're thinking sky blue and I'm thinking royal blue and ends up being blue cheese, that's kind of fair for the game. So those of you out there running MySQL, especially earlier versions, 5.6 reached end of life on February 5th of 2021. Please, please, please upgrade. It is vital importance. There's a lot of security bugs out there, a lot of new features. Please upgrade to 5.7 or even better yet, 8.0. 8.0 has been out for 3 years. So if those of you who are waiting for the early bugs to shake out of the system like every database has, we're long past that. Also, to get my bosses some money, if you want to try out for free the MySQL database service, this is MySQL and Oracle Cloud Infrastructure, managed by Oracle MySQL engineers, written by MySQL Oracle engineers. It's the full enterprise version of MySQL. You can get $300 in credits that are good for 30 days if you go to oracle.com/cloud/free. If you want to try the MySQL database service, it's out there. If you want to try our high availability option, where you get a NODB cluster of 3 nodes set up and running for you, that's fault tolerant and highly available, that's there. Also, if you want to try the HeatWave analytics engine and the autopilot machine learning tool that fits on top of that to adapt the server and your queries to the performance, that's all there. The more high power stuff runs through your credits a little bit faster. But if you stay at the low end boxes, $300 in credits will last you quite a while. So what is this session about? Often I've gone to conferences and seen something that looks very interesting in the session catalog and gone to the talk, and it's totally different. But today we're going to be talking about database performance, specifically MySQL database performance. And nobody really complains when the database is too fast. Well, they never say the word too fast. It's fast or fast enough. No one ever says, hey, can you slow down the database for me? It's just swamping my application. And if you go out on the internet and you start looking as a novice on how do you speed up up a query. It ends up reading like a Harry Potter novel. There's all these weird incantations and sacrifices and other stuff that you have to do. No, it's fairly simple engineering, and we'll talk about what goes into that. Now, the trick is you have to understand how this database server wants to run your query. And once you do that, you kind of have unlocked the magic of how things work. So in today's talk, we're going to be looking at the proper use of indexes, histograms. Hopefully we'll get into the locking options and some other ways to speed up your queries. Now, I got to warn you, this is a very dry subject. How dry? We're talking stale saltine cracker in September in the Sahara Desert dry. If you're looking for something flashy, entertaining, I'm funny, but I'm not that funny. This is a lot of text on screen. I wish I could do this with interpreted dance. I wish I could do anything with interpreted dance, but I can't. What I recommend is go out and download the slides from slideshare.net/Dave Stokes and read through that, and don't try to absorb it all at once. If you've ever learned a musical instrument, they didn't hand you the instrument and the works of Bach and say, okay, we'll be back on Thursday to check on your progress. Work on little bits first. And when you're trying to optimize queries, the biggest payoff you're going to get is work on the queries that run the most frequently. If you save 1/10 of a second off something that runs 100 times a minute over a course of a year, that's saving a great amount of time. Then work on the second most popular query. The big queries that run once a quarter or once a month, if you take 5 minutes off something that runs 2 hours, that's great, but it's not the best use of your time. And by the way, the optimizations will change over time as data use patterns change and the data structures change and things evolve. It's not a set it and forget it. You'll have to come back and monitor these things every so often. Now, sadly today, I can't go over system configuration, either of the operating system. If you're an old timer like me and you remember the early Linux kernels, or before that, some of the Unix kernels, there wasn't a whole lot you can do to configure other than change the source code and recompile. Now there's so much out there that it's absolutely staggering. Also, MySQL, I'm not going to tell you how to configure MySQL. My best advice there is on a fresh install, set the InnoDB buffer pool size to 75% of physical RAM and let the system take care of the rest of it. Also, I'm not going to go over hardware. This is hardware, something that could probably be its own 1-week course by itself very easily. The trick here is there's so many different options there that I don't even want to touch that. Same thing for the cloud. For those folks who are running the various cloud instances, MySQL is on everyone's cloud and everyone does it differently. And no, not everything is pure MySQL. Sometimes they have their own code to make things run differently. And sometimes it works great. Other times it doesn't. Also, I'm not going to go into networking other than advise you to keep your MySQL server on its own network as much as you can. Try to have a separate network for replication and or backups. Believe me, there's nothing like having an LDAP update going out with a DNS zone change when you're trying to do replication in the middle of a busy day. Also, I'm not covering data normalization. For those of you who don't know, data normalization is how you take your mountain of raw data and compartmentalize it into various tables. A table for customer information, a table for sales, another table for shipping, one for your employees, one for a contact list. That's called normalization. And the idea there is that you want to have the minimum amount of duplication you can as possible. Now, I do recommend what they call the third normal form or better. And I also want to augment that with the JSON data type. If you have what I call stub data, that's where in the past you've gone from an index into a table that leads to another index table, another index table, another index table. Rather than dive 18 levels to figure out what the color of a t-shirt is, put that in a JSON data column. You have a gigabyte of space in there, and you can slightly denormalize your data for efficiency. Also, you have to think about how you're going to use your data. If you are doing transactional data because you're selling stuff. Your data is, and its usage, it's going to look a lot different than someone who's tracking movement between cell towers of a device. As I say here, don't try to use a fork to eat soup, and know how you're going to consume your data. That's probably the one thing that a lot of folks stumble over. They can set up the scaffolding for their data, but they don't really think about how they're consume it. And as I say there on the bottom, if you want to win the Kentucky Derby, you're not going to train a dachshund. You're actually going to have to train a horse, and that's the way you get results. Now, the heart of all this, and the main thing we're talking about today, is the optimizer. Consider the optimizer the brain and the nervous system of the database. Just about all relational databases now have some sort of query optimization, and the optimizer wants to find the most efficient way to return the data that you requested, and they measure efficiency in cost. That's why they're called cost-based optimizers. Is this a MySQL-based presentation from London DBA? Yes, it is. A lot of this will carry over to other databases, but I am speaking about MySQL. The hardest problem, one of the problems, optimizing data queries is one of the hardest problems in computer science. It's actually relatively easy to write operating systems and schedulers compared to the number of things you have to juggle at the same time in running a database. Now, optimizers are written with assumptions, and what they want to do is they want to get the cheapest queries. And the way to start trying to evaluate between optional plans is go out there and get information about the data. And sometimes you'll see that the database doesn't have that information. Now, the query optimizer will take a look at your query after it comes off from syntax parsing and you've been checked for permissions and all that. And the optimizer wants to return things the cheapest way. And since the 1970s, most databases have used that measurement of cost as disk reads. Disk read is 100,000 times slower than reading out of memory. So the more stuff you can read out of memory, the better. Knowing where the data is exactly is the better. It's like going to the grocery store and trying to get a loaf of bread. If you know where the bread aisle is, it's a lot easier than running up and down all the aisles. Now, the optimizer knows the costs through the statistics, and those statistics are historical information. The trouble with that is, so like when I go to lunch today, if I want to go to my favorite restaurant, it's left out of the driveway, right at the stop sign, over the railroad tracks, and the restaurant's on the right-hand side. That's the way I've gotten there for the past several years. Unfortunately, this morning, I don't know that my neighbors blocked the street because he has a moving van there. There's a train across the railroad tracks, which I'd have to go around at another crossing. And by the way, the restaurant is not only closed today, but they moved to the other side of the street. So historical information can be great, but it can often mislead. And when the optimizer is misled, it picks a poor query plan. Now, something that MySQL does that other databases don't is that every time it sees a new query, it wants to optimize it all over again. Now, some databases like Oracle allow you to lock down the query, and the big DBAs get paid a lot of money for monitoring all that. And when the query plan starts becoming inefficient, they have to go back, change it, and then relock things down. By the way, you can change a little bit of that with optimizer hints, and hopefully we'll get to that later in the presentation. So if you have 5 joins, it's like tables A, B, C, and A, B, C, D, and E, and the optimizer has to figure out, okay, I have 5 different tables. How do I join them? Well, that's 5 factorial, or I shouldn't have that exclamation point up on the 120. 5 factorial is 120 different options for joining those 5 different tables. So you can see how this scales to crazy numbers real quickly to try to figure out the various options that are out there. Now, the key to this is learning how to use a command called explain. And explain, I can't cover a lot of it here. I'm going to cover some very interesting parts of it, but explain would probably take a good week or two to learn how to use it really efficiently. This is the explain syntax. I've been told this is a little hard to read. I need to update this. But if you fire up MySQL shell and type \help explain, you'll get this. Explain is prepended to a select, a delete, an insert, or replace statement. Hold on 1 second. Let me turn on the little laser pointer. So you prepend the word explain in front of a select, delete, insert, replace, or update. And when you do that, it will give some information about your query. And of course, to make the learning curve even steeper is that there are many variants of explain for MySQL. Explain has 3 formats. There's a tabular format, there's JSON, there's tree. We add explain analyze, and we have visual explain. You'll see all those in just a little bit. So for those of you just getting into query tuning, it's a steep curve at first, but you'll see how it works in just a minute. So let's use explain on a query. So we have a simple query. We're doing select star, which is the wildcard asterisk for all the columns in a table. And in this case, we're picking the columns from a table called city, but we're only interested where the country code is equal to GBR. So that's our query with explain prepended. Off to the left, there are some details of how the optimizer wants to run the query. And down on the bottom is the query plan. The optimizers determined that this is the optimal query to run. Now, Visual Explain is part of the MySQL Workbench product, and it will tell you some of the same information in a nice graphical format. It tells us that we're going to do a non-unique key lookup on the city table using the country code column. We're going to need to read 81 rows, and the total cost is 73.73. Now, this is the tree format, and this is a slightly different query. So we're going to explain format equals tree, and our query is select star from city, as we did before. But this time we're joining a second table called country. And where we're going to match up is where the city.population is equal to the country population. And as you can see, this is going to be an inner hash join. It's going to have to do a table scan on city. And it will tell us the cost and the number of rows that have to be read for each table. So country, you have to read 239 rows. And on city, we have to read 4,188. Now, to give you even more information, we have the JSON format. What's great about this is it digs down just a little bit deeper, and using the query from the previous page, it will tell you the number of rows examined, how well it knows the data, we'll get into filter later, the cost of reads, cost of evaluations, and the number of amount of data, 61K, that has to be read to answer this query. Now, something we added a little bit over a year ago is explain analyze. All the previous versions of explain that you've seen are based on historical data. Explain analyze actually goes out and runs the query and gives you real data. By the way, if you see a skew between the two, run optimize table on your, or analyze table or optimize table on your tables involved, and rebuild the statistics. One thing about explain analyze, if you have a real nasty query that's a resource hog and you run explain analyze during production hours, you may not get the performance you want. So we'll come back to explain in a little bit. Let's go on to indices. When I start talking to novice programmers at conferences or Zoom meetings and all that, they kind of roughly understand what an index is. Now, Wikipedia tells us a database index is a data structure that improves the speed of data retrieval. And that's a good definition, but it helps to have mental images of what's going out there. And I like to think of an index as a shorter version of your main table that has the indexed field and a pointer to your data. By the way, these indexes want to be stored in memory, which means they take up memory, which is always a bad thing in a database. And the more tables and indexes you have, the more memory feeds up, and there's more contention, and things can slow down. This is why sometimes you'll see a site where they add the first index and everything speeds up. They add the second index and things slowed back down. And of course, to ever increase that learning curve, there are many types of indexes. And part of that is, I'll skip over the syntax here, but part of it is there's just so many different options. As MySQL has matured over the past 25 years, we've come up with a lot of different algorithms and ways of doing stuff. And people found that various block size settings, various algorithms do different things for them. Generally, I recommend staying with just the standard index creation. Now, MySQL likes to store things in what is called a clustered index. In Oracle parlance, it's known as an indexed organized table. That means your data is stored with the index in one big table, and everything is sorted by the primary key. This makes it very easy in a B+ trees to do a binary search down to find quality searches or stuff like that. And for best performance, choose primary key column or columns based on your most performance critical queries. Now, your primary key doesn't actually have to be part of the key elements of your data. It could actually be something tertiary hanging on there for performance. We'll get into that in just a minute. But the idea is you want to have a good primary key. And by the way, going back and changing them later gets really expensive and nasty and messy. And it's something that you should pick a good one the first time and don't think about changing it. Now, mental image that a lot of people have, and I like to encourage this one, is that you have your index over here where you have your values and then a pointer to the data. And if you want to look at value 12, you go to your index and it points you to the row that you want. And if you think of an index as a small, fast table pointing at a bigger table, that helps a lot of folks. Now, for InnoDB, which is the main storage engine for MySQL and the one we'd love you to use, and the one that we pour most of our money into, your mental image should be that you have your various rows and everything's sorted by the primary key. So if you want the record for number 12, you go to this row and all the data is here. Secondary index. These are actually indexes that are for non-primary data, is the easiest way to say it. Now, secondary indexes actually point to the primary index. So when you're doing a lookup on a secondary, it's actually going to take that value, point it to the matching primary, and then go off to the row. Now, if the primary key is very long and secondary indexes will piggyback off that, it takes up more space. Now, for most of you, that's not going to be a big worry. I just want to put that in the back of your mind, that be careful to try to keep your indexes as small as possible. So let's create a table with a primary key. Create table T1. We have 3 columns, C1, C2, C3. C1 is an integer. It's not null. We'll talk about nulls in a little bit. Auto increment, which means every time you increase or you add a new record, a new row to the table, it will automatically increment by whatever value you have set, the value of what's ever stored in C1. And we're designating that as our primary key. This is how this table is going to be sorted. And then we have our 2 other columns. Now, an index is a list of all the keys, which in this case, it's going to be a list of all the C1s. And in the MySQL world, you'll hear key and index used interchangeably. We also do that with schema and database. It's just the way we do things. It's the way we group stuff. Other databases do it a little bit differently. Now, the primary key, once again, is a key for the index that is hopefully uniquely defined for a row, and you should not go around changing it. Now, the InnoDB storage engine needs a primary key, otherwise it doesn't know how to sort stuff. Now, if you don't have a primary key, there's actually rules out there where it will go out there and pick one up. Hold on one second. I need to open a door for a dog. Sorry about that. Now, the heuristics for what NODB will do to go out there and pick a primary key from what you have, or when it will default to a, at the last resort to a creating its own, are out there in the manual. I won't go through that. It's like reading the rules for football playoffs. It's not fun. Also like to advise you, don't use null values when you can get away with it. And also you want your primary key to be monotonically increasing. So records start with the ID of 1, 2, 3, 4, or 1, 3, 6, 9, 12. You want to increase at a regular rate. If you love UUIDs, UUIDs are not designed to be monotonically increasing. If you must use a UUID as a primary key, you can have UUID stored in there. I just don't like using them as primary keys. Use the UUID to bin function, and it will store your UUIDs as a var binary 32. Now, sometimes when you know your data, you can index only part of it. In this example, we're going to take the customer name and just index the first 10 characters. This is great when you have names where the first 10 characters will probably identify 90 to 95% of anyone calling up or being searched for. And this actually does save some space in the index and can save speed. You might get a few more rows returned than you want, but like when you call a doctor's office and they want your name, date of birth, and phone number, they're probably indexing on part of all of those to find your record. Now you can index multiple columns. In this example, we're going to create another table where we have a primary key on this ID column here. We have 2 columns for last name and first name, and we're going to index last name and first name and call that index name. Now, this index will work on last name and first name, or just last name. But this is something I'm going to have to correct in my slides in the future. But it may not work for first name if you're running a version before MySQL 8.0.13. You want to put the highest cardinality or the most unique field first in the index when you set this up. And let me add a caveat to that I'll cover in just a second. You can also hash values. Hashing, if you don't have something that makes a good primary key and you have 2 values that are going to be unique, you can concatenate those together and run through an MD5 hash function. Now, as I mentioned, this learning curve gets very, very steep. Unique indexes are where you're only going to have 1 row per key value. This is the fastest way to do stuff. We also have full text indexes. So if you're searching for strings within your data, it's designed for that. It's kind of like the Elastic Stack, but if you really have a lot of that to do, I really recommend Elastic Stack. Now, the great thing about the full text search of the DB storage engine, if you're looking for 2 words like fire and truck, you can put in a limit in there that they must be within X amount of words of each other. Sometimes that helps you narrow down your search. Covering indexes, we'll show you one of those later. That's where all the indexes, all the data you're trying to retrieve from the query is actually returned from the index alone without having to read the data table. I've gone into secondary indexes a little bit. And spatial indexes. We use the Boost Geometry C++ libraries in MySQL. So if you want to write your own Google Maps type thing where you're going to have your own longitude and latitude and trying to find the nearest fast food restaurant, you can actually set up a spatial index for the other longitude and latitude locations and compute that information. Also, we have functional indexes. These work with only part of the data in a column or a derived value from the column. And in the example below, we create a table called birthdays, and we're going to have a date type column named birthday, and we're going to index just the month of the birthday. So we do a select from birthdays where the month equals 12. it's actually going to use that functional index to return our information. If you don't like that, or there's something that doesn't quite work that way for you, your computations are off, we do have generated columns, which is where you extract part or whole of a value from another column, and you can do some computations on that and store that separately, materialize in its own column, and then index that. Something else you can do rather interesting with index columns is, here's an example where a customer wants to go out and buy something from us, but the cost plus shipping has to be under 100 value, the value of $100, yen, pounds, whatever. So in this example, we've created an index on the product where we have cost plus shipping. So when we do search for cost plus shipping, it will use that index. Now the caveat here is the order of cost plus shipping. What I'm talking about is here on the left, we've defined the index as cost plus shipping. But if our query, we slip and we forget and we try to do it shipping plus cost, it has to do a table scan. Table scans are where the entire table or file have to be read to return your information. That's not efficient. If you can get an index that works better. Now, sometimes table scans are needed because you're doing end of year processing, end of quarter processing. You have to go through all the customers or all the sales records. So full table scans aren't always bad. But in a case like this, where you have a beautiful index up here, you have to make sure that if you define it as cost plus shipping, that you use it as cost plus shipping. Otherwise, you're not going to get the performance that you want. Also, when we introduced the MySQL JSON data type back in 5.7, people started using the JSON data type for array storage. MySQL does not have an array data type, but a lot of folks found it very easy to use it as such. Now, the trouble there is that when you wanted to search for that, at the time this was introduced, you had the limitation of one row in the data table matching one row in the column of the index. So what happened with that is we developed a way to do multi-value indexes. So we can actually index every one of these values in the array. And to find out if the array has a value in there, we're going to select and we're going to see if the value 3 is a member of this array. And in this case, it is, so it returns a 1. So let me reiterate big rule number 1. Always have a primary key on your InnoDB tables. It saves you so much hassle and effort. And once again, always do it. Now, if you don't pick an index, let me reiterate, InnoDB will pick one for you, and it will probably not be what you need. And it might be what you deserve, but it's not what you need. Now, for those of you who have been running your instances for a while and you're wondering, gee, how do I find out if I have tables without indexes? Here's a handy query. Go out and copy this from the slide deck, and it will tell you which tables do not have indexes. Now, sometimes you're running an application, especially older PHP applications, where the application does a select star from table T1 and uses that data. It doesn't name explicitly the columns that it wants. This is not great programming, but it happens. Now, you want to add a primary key for performance, but you can't do that because it's going to screw up your programming in your old WordPress add-in or plugin. So one thing we have is invisible columns. So if we're going to alter table T1, add a column named K. If you do a select star from T1, you're going to get all the values except for K, because K is marked invisible. To get all the values of T1, you have to do select star T1, comma K. By the way, MySQL has two main types of index structures. Most of the time, you're going to see B trees like on the left. This is a very simple binary. It's actually a B+ tree, but for those who are really worried about it. you have this trunk here. And by going down traversing the trunk, you find out where these leaf nodes are. So if you're looking for the value of 120, you know, to let's do the value of 250. You know, you have to go through this intermediate node to this leaf node to get your data. And by the way, these leaf nodes are all doubly linked lists going back and forth between them. So it's easy to traverse. Now, something we introduced a little bit over a year ago is hash joins. Much faster for a lot of queries. Don't have to do anything to turn them on. If you're doing an equijoin where x dot t1 is equal to y dot t2, the optimizer will try to make it a hash join. In that case, it will take the smaller table, put it out in memory, and then try to merge that with the bigger table. And oftentimes that's many factors of speed faster. Now, part of the heuristics that you got to remember is that MySQL wants to pick between two indexes. If it has two indexes to pick at, or three indexes, it's going to try to start with the one with the smallest number of rows. It figures it's the most selective, has the highest cardinality. May not be true. The more you're working with data, the more you'll understand how these things work. But for the first time it sees something, it's going to want to start with the smallest number of rows in an index. Also, you have to compare apples with apples and oranges with oranges. If you're evaluating a character with a decimal, there's some casting that has to go on to slow things down. Now, if you're comparing a varchar with a car and they're the same size, that works great. But if it's as you see there, a varchar 10 and a char 15, that's not a great comparison. Things have to be casted, and sometimes indexes will be bypassed because that's not, the optimizer not recognize that as a good choice. By the way, try to use the same collation and character sets for your data. So MySQL 8 is optimized for UTF-8 and before to give you all the panes of the all four panes of the 9.0 Unicode character set. So you get the Chinese, Japanese, and Korean characters plus emojis. But if you're using an older 1-byte character set like Latin 1, comparisons, everything has to be cast and then compared, which slows things down. Null. For those of you new to databases, null's one of those things that you stumble into and they make you scratch your head wondering why. Well, in the early days of computers, you basically had two types of data, binary data, 1 or 0, true or false. Now, what happens after a while, they started realizing, well, what if we don't know the value of a piece of data? How do we denote that? We can't use 0 because it's not false, and we can't use true because it's not true. And that is how null came about. And that has caused a lot of consternation ever since. Try to keep null out of indexed fields and really only use it in cases where you know that you don't know the value. Here's a handy little graphic to help you mentally picture what the difference between 0 and null is. Now, if you do have an index with null values, it really drives down the performance of your indexes. It's like having a junk drawer. You know where everything else is in your kitchen, and the last place you want to search is that junk drawer because it's all in order, it's messy. That's an analog of what happens to an index when you have null values in there. Now, as I mentioned earlier, sometimes you can create what they call a covering index. where the items in the index answer the fields in the query. And when you hit that, it doesn't have to read the data table. It pulls all the information right off the index and away you go. Now, here's an example of that. We have, someone's asked, can someone tell me what customer and the total of what they bought from a particular salesman from the orders table? And we want to know about customer where their ID is 101 and the salesperson's ID is equal to 7. And we want to make sure that they bought something with a value greater than 1.0. So if we look at that with Visual Explain, it tells us on the orders table, we're going to have to read the full table, and the cost of that is 1.5. Now, this is a very small data set. If much more records out there, more than the 5 rows we actually have out there, this performance really goes downhill. So let's change this a little bit. Let's index on the customer ID and the sales ID, the first 2 of the 3 items in our query. And when we do that, the cost goes from 1.5 overall to 0.7. Well, that's 46% better. And once again, this is a small data set. If it was a bigger data set, you'd see more of a skew here, but this is good for illustrating. Well, how can we make this even better? Well, if we add an index covering all 3 of the fields that we're trying to return in our query, the covering index, the cost goes from 1.5 to 0.7 to 0.66. Now, 0.7 to 0.66 may not seem like a big win, but imagine you're doing this 10,000 times a minute. That time does add up. Invisible indexes. When I first ran into this concept, it kind of puzzled me for a little bit, but it's actually kind of neat. Now, in the days before invisible indexes, if you had a index that you weren't quite sure was doing you any good, what would happen was you'd run explain on a query, and that index is there, and it's taking up an awful lot of memory, and you want to freeze up memory for something else. So you check your query using explain, it reports back that it doesn't use that query. So you remove that index. And as you're rerunning explain, suddenly you get a phone call or a text or screams from down the hall, usually from a power user, about everything suddenly running really slow. And about that time, you realize that you blew away an index that you really need. And everyone in the world now seems to hang on the line waiting for that index. So you start trying to rebuild it, and sometimes it takes seconds, other times it takes minutes, hours, days, weeks, and sometimes you don't remember what everything was indexed and in what order. So this can become rather messy. Now, after invisible indexes, what happens is you doubt the index, you check using explain, you make that index invisible. The optimizer cannot see that index for the entire server. As you rerun explain, that power user comes back and starts complaining, and you make the index visible again. And then you blame the problem on the network, JavaScript, GDPR, Slack, the cloud, whatever you want to. But you don't have to go through that painful and expensive rebuilding of the index. By the way, the sys schema, which is part of the instrumentation with MySQL 8, it's been around since 5.7. We'll show you which indexes have not been used, and that may be candidates for removal. Well, what do I mean here? Whoops, so I'll get back to that side. Okay, how to use an invisible index. With a simple alter table, alter the index and declare it invisible. If you want to make it visible again, you just alter the table, make the index visible. Once again, when you make it invisible, the optimizer cannot see it for the entire instance. I'm going to skip over index extensions for time's sake. Now, if you have indexes that you aren't using, you can use MySQL Workbench, and under the performance reports, you can get a report of unused indexes. And in this case, we have some for performance schema, which is part of the internal instrumentation for MySQL. But in my demo schema, I have several indexes that aren't being used. Now, if you want to get rid of an index, my big advice is make it invisible first. Why is that? Well, it might be an index that hasn't been used in a while. It might be something important for end of month, end of quarter, end of year. It also might be that the system is just rebooted and the statistical information for that index haven't been built up yet. So if you have an index that you kind of want to get rid of to save memory and overhead, make it invisible first and watch it for a while. And for those of you not running Workbench, here's a query that will go out and do essentially the same thing as what that one you saw from MySQL Workbench. And it's going to get information performance schema and look at how the indexes have been used. Also, something you want to monitor is tables with full table scans. These may not have indexes. If they don't have indexes, you might want to create an invisible one. As I mentioned earlier, full table scans aren't always bad, but if you're doing the DBA work, even if you're not a DBA, it's something to keep an eye on. Okay, histograms. This is the second half of this talk. And histograms were introduced in MySQL 803 years ago. And no, it's not a gluten-free, keto-friendly biscuit. What it is, it's a graphical representation of the data. Now, in this case, here's a bell-shaped curve where someone's gone out and measured the height of 10,000 US females in centimeters. So Wikipedia tells us histogram is an accurate representation of the distribution of numerical data. And then it says for our relational database management system, histogram is an approximation of the data distribution within a specific column. Well, those things tend to not match up there, but that's Wikipedia. So in MySQL, a histogram helps the optimizer find the most efficient query pan because it knows the distribution of the data. Well, how does that work, Dave? Well, we have two types of histograms. Singleton, where each logical bucket that you're going to put your data in has one value, or equiheight. You're going to take all your data and spread it over 5 different buckets. So each bucket has 20% of your data. Now, the maximum number of buckets you can have right now is 1,024. Now, you'll want to use histograms on non-indexed columns. A histogram is created or updated only on demand. So there's no overhead as the data changes. Now, the only trouble as the data changes underneath the histogram, it gets less and less reliable. So you might need to update it on a semi-regular basis. Now, why would you want to use a histogram instead of an index? Well, maintaining an index has a cost. If you have an index entry, every time you do an insert, an update, or delete, the index has to be maintained. And that has an impact on performance. Histogram doesn't have that. You create it once and run it till you do it again. So it's not going to hurt your insert, update, or delete performance. Also, from time to time, the optimizer will make index dives to recalculate the statistics of the indexes. And of course, you can't schedule this, so it will happen at inopportune times. Now, occasionally the optimizer fails to find the most efficient plan and ends up giving you a less than optimal query to be executed. Now, part of this happens because the optimizer assumes that in a column of data that everything is evenly distributed. Well, that doesn't happen all that often. So among the things that the optimizer wants to know is how many rows are in each table, how many distinct values, or the cardinality in each column, and how the data is distributed. And we're going to show you how to look at the distribution in just a second. Now, as I mentioned earlier, we have two types of histograms. The equiheight, where one bucket represents a range of values. Think being assigned alphabetically to a bucket, A to G, M to L, M to T, U to Z. And there's the singleton, where a bucket represents a single value. So here's an example where we have 3 buckets. 101, 102, 104. Have no idea what happened to 103, but we have 3 buckets and we have 3 different values. It just happens that we have 2 101s, 3 102s, and 1 104. Now, here's our table with the data in there with our 2 101s, or 3 102s, and 1 104. We create a histogram for 3 buckets. And if we take a look in the information schema, it tells us that the value of 101 is 1/3 of our data in that column. That 102 and below is 83% of the data in that column, and that 100% of our data is 104 or below. Now, when the server goes to read your data, it just can't read the couple of rows you want. It has to read a whole page of data. And if it knows the distribution of the data, it's more efficient at grabbing those records. If you look at the cumulative frequency versus the frequency, you can see that 102 is 50% of our data. So if we want to grab that, our distributions here is going to take 50% of our rows, which gives us an estimate of the number of rows that have to be read. So we know we have to read half of our rows. Now, adding and creating histograms is real easy. The first example, we're going to say update histogram. Even though it's for the first time we're creating it, there is no create, just update. And we're doing it on 3 different columns, each with 10 buckets. Later, we come and update the histograms on 2 of those columns, and we drop the histogram on C2. Now, if you want information on histograms, that's very easy to find. You can go out once again to the information schema and look at the statistics. We find the table and the columns that have histograms on them, the data type, and the number of buckets. Now, here's an example to show you where histograms shine. We're going to create a table called H1 where we have an ID field and an X value. And we insert into our table 2 1s, 3 2s, and 4 3s. And if we select everything from the table, we have 2 1s, 3 2s, and 4 3s. Now, without a histogram, and we run our query, the optimizer returns what information it has. Now, remember, it hasn't seen this data. We just created this data. It doesn't have a lot of historical information on it. It has a little bit, but doesn't have a lot to give it a good fuzzy feeling about the accuracy of its estimate. By the way, if you've ever dealt with a mechanic or a contractor who gives you bad estimates, sometimes people just can't make good estimates. Sometimes they don't have all the knowledge. And this is a case where it doesn't have the knowledge. Now, in this example, we're going to select everything from H1 where X has a value greater than 0. Let me go back a slide. X, everything has a value greater than 0. So logically, we're thinking, okay, we've got to read everything in that table, and we have 9 rows. Well, in this case, the optimizer doesn't know that. So it's guessing, and it is a guess. We're going to have to read about 1/3 of those 9 rows. Now, the closer you have the filtered up to 100, the better. But in this case, it doesn't know about the data, and it figures, well, I'm going to have to do 1/3 of that. So I'm going to have to read, I guess, about 3 rows. Imagine this is Labor Days, and you have to pay for, it says, yeah, it's only going to take me 3 days to build this. And you know that it's going to, in the back of your mind, that's going to take 9. So that you know the estimate's wild and inaccurate. So let's add a histogram on our table. And we rerun our query. Once again, where X is greater than 0. It now knows that all the records are above 0. So it knows that it's going to have to read 100% of the 9 rows. Now, you're going to be less upset if this was someone working on your motorcycle that says, yeah, I can do it in 3 days, and it ends up taking an extra 6 days. Then if they say, yeah, it's going to take 9 days, and you come back 9 days later and everything's fixed. This is running the same query with explain analyze. It helps to, when you're playing with different things, to run explain analyze from time to time to see what the actual costs are. Now, performance with MySQL is just not indexes and histograms. There are lots of other things you can do. What's interesting when you get better with explain is you'll see notifications of file sorts. For some reason, the server is taking the data that you've requested and it has to write it out to disk and then do some sort of sort on the disk and then pull it back and push it down the wiring to you. Sometimes you can get away from doing that with indexes on the column that's being sorted on. Also, temporary tables. In the past with MySQL, before 8.0, if you're using a temporary table, it would work for X amount of data. When it hit a hard limit, it would copy everything over to InnoDB and then restart processing. Well, that stopping, copying, and restarting was very expensive. MySQL 8.0's temp engine is a lot better. But occasionally you still see that it needs to force to use a temp engine, and you need to investigate on that. And sometimes you look at the query plan and the join order doesn't look right. This is much like a programmer's code smell. You know the optimizer is doing something wrong, and you get through that with optimizer hints. Then other times you have to start investigating cache hit rates. Do you have enough buffer and cache space to process the data that you want? And you actually get that out of the sys schema or the information schema. By the way, the next last entry on there, do you have enough memory? The answer for anyone who deals with databases is no, you never have enough memory. Now, the bottom one there, disk and IO speeds, are they sufficient? Well, this has changed a lot in the past couple of years. It's going to change more. Disks are incredibly cheap and fast, and the IO rates are amazing. However, once again, this is the thing where you can always go bigger, faster, better, stronger. Now, two things they added with MySQL 8.0 are locking options that do some neat things. The first one is the no wait option. Before this, if you were trying to lock a record and someone else had it locked, your query would wait up to a certain delay time where it finally gave up and decided things were deadlocked. But it would wait. And if you want to search for records in a group and you don't want the locked ones, but you want the ones that aren't locked, no wait will let you, well, no wait says if you can't get it, return right away. Skip locked if you're going after values between 100 and 150 and number 139 is locked, it'll grab everything else but number 139. Here's an example. We want to buy seats for a concert, and we're looking for seats numbers 3 and 4 in rows 5 or 6. And we want to find the records that aren't already booked. And if we find them, we want to update that, but we want to skip any locked records. So maybe we can find seats in row 4, but not in row 3. Now, if we do the same query with no wait, and those records are not there, it comes back immediately, says, hey, we can't, you could put logic in your application. Hey, rows 5 and 6 aren't there, but let's check row 7. By the way, without the no wait, what would happen is after 50 seconds, which is a hellaciously long time in the data world for waiting to acquire a lock, things would time off. And when that timeout hits, you get an error 3572. Now, there's some other things you can do that are fairly easy. The first one is a resource group. Everyone these days is running on multiple core processors. And what we do is we decide we want a low priority group for batch processing. And what we do is we create a resource group called batch. It's a user type resource group, and we're going to take virtual CPU 2 and 3 and assign it to a very low thread priority of 10. So if you have information coming back from a bulk mailer you want to input to the system, but you don't want it interfering with transactions or some other high priority stuff, you can assign it to this resource group. Now, when you start a session, you can say, okay, my resource group is going to be batch. or you realize someone's doing bulk inserts, you can go for them, find out what thread they're on, and set the resource group for them. Or in your query, you can put in this comment to say, okay, the resource group is batch, and put that right in the front of your query. The optimizer will realize that, and it will be scheduled to go into that batch resource group. Now, you saw this resource group equals batch in the query. There's a feature we have called optimizer hints. This is something to be a good 2-day class, and one of these days, going to write that up. But there's all sorts of things you can do with resource groups. You can change the join order. You can do subqueries, a whole bunch of other stuff, and how subqueries return. Just wanted to mention this to give you an idea that it's out there. I didn't want to really cover this today. Also, something else you can do is partition your data. And in this example, we have a date column named join, and we're going to partition by the year field in that date for various records. So like these are guitar parts. So if you're looking for a bridge for a 1973 Fender Stratocaster, you know it's going to be in this partition. Now, when the data is partitioned like that, the optimizer knows not to search these other partitions. It knows to concentrate its efforts only on that partition. So if you have a lot of time series data, this can save you a lot of processing time. I mentioned earlier MultiValue Indexes. This is mainly used with JSON data. And an example here is that we're going to get the zip code. By the way, folks who are outside the US, zip code is a postal code. It's usually 5-digit or 9-digit. And in this example, in our JSON column, we have a key with zip code as the name, and we'll have some value behind that. And this will cast that information into an unsigned array and then add an index to it. So some point in your time where you're working on queries, you got to ask yourself, does it work? Does the effort match what you want to get out of it? So when you're testing your queries, use explain. And I don't care if it's visual explain or the explain in the MySQL shell. Use explain to get information on the query before making changes. And the reason that is you want a baseline, you want a benchmark, you want to know where you're starting out at. And also go out there and show index on and then table name to look at the available indexes. Maybe the indexes are out there and you don't want to reinvent the wheel, or maybe the columns in a multi-column index are just not in the order that you need. Now, once you find out that information, start making one change at a time and compare the performance after that change to your baseline. If you make multiple changes, you don't know which one really paid off for you, and you need to know that about your data. Now, as you make these changes and you start getting good results out of it, and by the way, sometimes you have to take 2 steps back to get the 1 step forward. Start deciding, when is the performance at a sufficient level where you can stop trying to optimize. You either hit diminishing returns, or you get to the point where performance is acceptable, you have other problems, and you'll come back to us later if you need to. Or you get to a point where you're just frustrated, you're not making any changes, and you just decide to come back to it later. And by the way, document your changes. There's nothing like being in a staff meeting and hearing, hey, Dave, that change you made 2 months ago really speeded things up, but this is now going slower for something else. Make sure you document so that when you run into a problem later, you can have details of what you changed and how you changed it. By the way, if this was fascinating to you, I'd like to recommend 2 books by a former colleague of mine. He's a wonderful writer. His name is Jesper Wisborg Crow. He wrote a wonderful book called MySQL Performance Tuning. He has a real good writing style, explains things very well, makes a lot of complex subjects very, very easy. And this is all about improving execution speed of queries. A lot of the stuff I covered today and a lot more. Also, he had wrote a book on MySQL concurrency for those of you who are really into locking and transactions. I recommend both these books highly. This is another great book, but it's dated. It is the third edition covers up to MySQL 5.5, so it is quite old. It has a lot of good base background information, and the best thing about this is you usually find this in used bookstores rather cheaply. Make sure you get the third edition. First and second are good. I have all three of them, but the third edition is much larger than the other ones, and it's the latest version, even though it's quite old now. Supposedly there's another version of this in the works, but I do not know about it. Also, if you're working with the JSON data type, I'd like to recommend my book, MySQL and JSON, A Practical Programming Guide. The MySQL manual is great for explaining how things work, but doesn't have a lot of examples. Also doesn't get into best practices. The first edition was very popular, and I came up with a second edition because we added so many features, like things like JSON table. JSON table lets you take your unstructured JSON data and temporarily turn it into a structured SQL table for processing by SQL commands. Also, I covered generated columns where you take your JSON unstructured data and structure it as a materialized column by itself in a relational table. Also, it's also a great introduction to the MySQL document store. That is our NoSQL database on top of MySQL. So you get the JSON document store functionality, the ease of use, low cost of entry, built on top of the proven performance of the MySQL server. Also, if you're in a startup, Oracle would love to talk to you. We have lots of cloud credits and discounts and lots of promotions, and we'll channel you into our 4,300 or 430,000, sorry, customers out there. It's a very good program. I'm one of the ambassadors for this, and it has helped a lot of businesses out there that are just starting up. And with that, I'd like to remind you the slides are out there, slideshare.net/Dave Stokes. Look for MySQL indexes and histograms. If you want to get hold of me, there's my email and my address on, or my handle on Twitter. I have a blog called elephantdolphin.blogspot.com. I tend to talk about things related with the PHP world and things I find new about MySQL. MySQL has its own blog aggregation site called planet.mysql.com. Anyone who's doing something in the MySQL world, we put all their blogs together so it makes for easy reading. By the way, if you have questions, forums.mysql.com, our engineers are out there and they monitor that information. So if you have a question, usually very shortly, you can get a nice answer back. And with that, I'd like to open everything up for questions and see what, if any, questions you have. I know there are several of you out there, but I had only that one question. So if you have anything, please let me have it.
In the meantime, while anyone's typing their questions, Dave, I just want to say thank you. That was an excellent presentation. Very well done.
Thank you, sir.
And for what it's worth, everyone, there will be a survey that will be going on, I believe, in a couple of days, if not next week, that will have session evals for everyone and all of our speakers. If I would encourage everyone as a fellow speaker to please give us a few minutes back and just, give us some feedback as to how we can, each one of us can improve our different sessions and that sort of thing. This is a, something that a lot of us do, for the love of it, if you will. And, we always want to, keep on improving. So your feedback is very valuable to us. So, but otherwise, yes, please throw in any questions you may have, whether it be to the into the chat or into the Q&A. So,
well, thank you, Peter A. By the way, the feedback is very valuable. Matter of fact, I'm writing a book on this because I had some folks saying, "Hey, you didn't have time to cover this. You didn't have time to cover that. I want this example on how to do this." So your feedback is precious, not only to the organizers to figure out what the audience wants, but to the presenters so we can tune our presentations. And by the way, you too could be presenting next year if you wanted to. I'd like to put that out to you.
Yeah, that's the cool thing about GroupBy, and there's other virtual events that are out there, and there are many of us, myself included, that will be willing and able to help you and mentor you to get into speaking as well. So that's something that many of us love to do, is try and grow new speakers as well. We don't want to be the only ones doing this after all for however long. So, all right.
Okay, well, thank you all for having me. I will stop the share here. If you're too shy to get a hold of me, you have my email address. And have a great day.
Thank you. You too.
Thank you.
I'll talk soon.
Cheers. All right. So it looks like we got a couple of minutes to kill before the next before what is it? Minionware's up next, right?
Where, yes, correct. Yeah, so everyone, grab a coffee, take a minute. We'll be online with that shortly. I'm just gonna hop over to the track, make sure they're all doing good there, but you're in great hands and we'll talk soon.
Woohoo. So go grab some food and grab a snack. Otherwise, if anyone wants to chat, raise your hand, and I can even allow you to talk if you just want to shoot the breeze and kill a few minutes. We can